everyone. Welcome back for more economics. I know the first class after an exam is usually not attended well, so thank you for actually coming in today. So just a couple of kind of FYI announcements about the exam. There's a big learning curve to taking exams on Blackboard, so I acknowledge it's always kind of difficult the first time. That said, if you got a score that was not what you were hoping for, don't panic yet. I've emailed several students and just given them the encouragement that the first exam is only 20% of your overall grade. So if you didn't do wonderfully, don't feel like you have to drop the class yet. That said, you definitely do need to go back and look at the questions you got wrong to just figure out what material you're not understanding, because the final exam will be cumulative. So if you have any questions as you're going through the solutions, definitely reach out. I'm happy to meet. Again, I'm going to put another plug in for SI sessions, so you get free tutoring there, so definitely take them up on that. What we're going to do today is we're going to get started on Chapter 5. Chapter 5 is a big chapter on elasticity, which you do not know what it means yet. I'll explain it to you. And there's different flavors of elasticity, so today we're going to be looking at elasticity, price elasticity of demand. And then once we kind of get a firm handle on that, we're going to jump into some other types of elasticities. Okay, but first of all, what is elasticity? So let me just kind of give you a general definition of this. Okay, the idea of elasticity is we want to measure how responsive somebody's quantity demanded or quantity supplied is to a change in something else. So the idea is if something changes in the world, how much do demanders cut back on their quantity demanded, or how much do suppliers cut back or ramp up on their quantity supplied? So in a general sense, elasticity is a measure of how responsive quantity demanded or quantity supplied, it depends on what you're looking at, is to a change in some other variable. Okay, so again, the idea is some other variable is going to change, and then we want to know how much does quantity demanded how much is it affected, or how much is quantity supplied affected. So just as kind of some examples here, sometimes we measure price elasticity. So price elasticity means that the sum other variable is price. So the idea is if price changes, then how much does quantity demanded change, or how much does quantity supplied change? Another example is sometimes we look at income elasticity. So the other variable is income. And the idea is income elasticity measures if income changes, well then how much does quantity demanded of a good change, or how much does quantity supplied of a good change? Okay, so this is kind of the generic definition of it. What we're going to do today is we're going to focus on the price elasticity of demand. Okay, so this is the focus of today. Okay, just based on the term, you can kind of figure out what we're going to be thinking about. So the idea is if we're measuring price elasticity, then the sum other variable is going to be the price, and then it's the price elasticity of demand. So we're going to be looking at how changes in price, in particular, change quantity demanded, or how much quantity demanded is impacted by a price change. Okay, so just so you have this in your notes. So the price elasticity of demand is how much the quantity demanded of a good changes or, in other words, responds to a change in the price of that good. one thing to just kind of keep in mind, what we know is that based on the law of demand, if the price of a good falls, the quantity demanded increases and vice versa. So we know, just based on like the very beginning things that we've learned, that when we have a downward sloping demand curve, if you change the price and move it down, quantity demanded goes up. What we're grappling here with elasticity is if you change the price, like how much does quantity demanded go up? Because this situation, where you have a steep demand curve, is actually very different than this situation where you have a demand curve that is not steep at all. So just eyeballing this, suppose you have a price that starts out here, and so in this market you have this many units and this many units in the other market that are demanded, and then the price changes and it goes down to here. Well, in this market, the quantity demanded went up by just a little bit, but in this market, the quantity demanded went up by a lot. So elasticity is going to help us capture this. It's going to say, okay, given a price change, like how much does quantity demanded change? Like how responsive is the quantity demanded to a particular change in the price of a good? Okay, so to measure this, what we're going to do is we are going to compare two numbers to each other and then think about which one is bigger. Okay, so get the right marker out. Okay, so what we're going to do is we're going to compare the percent change in the quantity demanded to the percent change in the price. Okay, the idea here is if a price starts at $10 and it goes down to $5, well, that's a 50% change in the price. Okay, if the quantity demanded starts at 100 units and it goes up to 200 units, that's a 100% change in the quantity demanded. So we know anytime we change the price, we're going to get a change in the quantity demanded, but what we want to compare is which one of these two things is bigger. If you have a particular change in the particular percent change in the price, and that leads to a percent change in the quantity demanded, well, in terms of magnitude, which of those two changes exceeds the other? Okay, so I'm just going to give you some facts, and then we'll talk about the facts. Okay, what's going to be true is if quantity demanded is very responsive to price changes, so price, that's the delta, changes, then what's going to be true is that if you have some change in the price, then the percent change in the quantity demanded is going to be even bigger. So this is what's going to be how the world is going to look like if quantity demanded is super, super responsive. So again, this percent change would exceed this percent change. Okay, so what that would mean is that the percent change in the quantity demanded, we're going to put absolute values around this for a reason I'll explain in a minute, that would be greater than the percent change in the price. Okay, why am I putting absolute values around this? The idea is that price changes and quantity demanded changes always move in reverse. So if the price goes up, quantity demanded goes down. If price goes down, quantity demanded goes up. So if one of these things is negative, the other thing will definitely be positive. So they're always going to move in opposite directions. So what we want to think about is not like the sign of the change. We want to just think about in terms of magnitude, which change is bigger. So we're just going to drop the negative on whichever side has the negative and just look at the raw like magnitude or the bigness of the number. Okay, if this is true, then if you stack these two variables on top of each other, then the percent change in the quantity demanded, if you put it over the percent change in the price, well, if this thing is bigger than this thing, then that whole ratio is going to be larger than 1. And we are going to call this an elastic demand. Okay, sometimes students, they get like really stuck into the details, but they don't take their head up and just like think that this word actually makes sense. Okay, if you have a rubber band, it's super elastic. What does that mean? It's super, super stretchy. So if you pull it a little bit, then you actually get lots of responsiveness in terms of like how far it spreads. So an elastic demand is going to be one that's kind of super stretchy. So if you have a particular change in the price, the change in the quantity demanded is going to be like pretty extreme, like it's very responsive. And so when that is true, then when you take these two terms that we're interested in and you stack them on top of each other with the percent change in the quantity demanded on top, because the numerator is going to be bigger, the whole ratio is going to be bigger than 1. So this inequality, where the elasticity is greater than 1, is going to be labeled a very elastic demand. Okay, what would be true if quantity demanded is not very responsive? So another possibility is that you change the price and you don't get much movement in the quantity demanded. So if quantity demanded responds only slightly to changes in the price, then what is going to be true is that when we're comparing percent change in the quantity demanded in terms of its absolute value to the absolute value of the percent change in the price, well, if this thing only slightly responds when this changes, then the inequality is going to be like that. So whatever the price change is going to be bigger than the residual percent change in the quantity demanded. So if we stack these two things on top of each other, then we would get the percent change in the quantity demanded over percent change in the price. Well, if this thing is pretty big, if the denominator is bigger than the numerator, then the whole ratio is going to have to be less than 1. Okay, if we find this to be true, then what we're going to say is that this inequality, where the whole ratio is less than 1, is going to characterize an inelastic demand. Okay, again, the word is very descriptive. So if something is not very elastic, if it's inelastic, it means it's not very stretchy. So you change the price by a little bit and you don't get much pull in the quantity demanded, so it's going to be inelastic. Okay, so that's kind of the overall summary. So now let's think about what affects whether a good is elastic or inelastic. So what I'm going to do here is just make a bucket list. So these are going to be determinants of price elasticity of demand. Okay, there's going to be 4. All right, determinant number 1 is going to be, I'm going to write first and explain, is going to be the availability of close substitutes. Okay, we've talked about substitutes before. Substitutes. Okay, so what is a substitute? So as we've discussed before, different goods are related to each other. So if you have 2 goods that are substitutes for each other, that means you can kind of use them interchangeably. So grape jelly and strawberry jelly are substitutes. Like if you're making a peanut butter and jelly sandwich, you could use grape jelly, you could use strawberry jelly. So you can just kind of use them interchangeably. Okay, so what's going to be true is that what's going to determine the price elasticity of demand, or one of the determinants, is going to be how many close substitutes there are for the good. So the rule is going to be that goods with more close substitutes are going to have more elastic price elasticity of demands. Okay, so goods with close substitutes abbreviate there, have elastic demands. Okay, so let's just like think through this in terms of an example. So what's a good that has a lot of substitutes? Well, if you're standing in Publix in front of like the deli meat section, the smoked turkey has a lot of close substitutes. So when you're making a sandwich, you can use smoked turkey. You can also use roasted turkey. You can also use the ham. You can also go with roast beef. So there's a lot of things that you can use and substitute for the smoked turkey. So what that means, according to our rule, is that smoked turkey that you use for sandwiches is going to have a very elastic demand. Okay, think about what that means. That means if you take the price of smoked turkey and you raise it, you're going to get a big reduction in the quantity demanded, and that makes sense, right? So if you're standing in Publix and the price of a little box of smoked turkey is $10, you're going to buy 0 of it. So that's like a huge reduction in your quantity demanded. And why do you do that? Because you're just going to take a step over and like grab the box of ham instead. Okay, think about this in terms of goods that do not have close substitutes. So one example of a good that does not have close substitutes is the gasoline that you put in your car. So suppose the price of gasoline goes up. I can't, as a consumer, say, well, gas prices went up. I guess I'll just put like vegetable oil into my car. Like, that doesn't work. Like, there's really no other good substitute for gasoline. And so because they're not close substitutes for gasoline is going to have a very inelastic demand. So in other words, if the price of gasoline doubles and it goes from like $1.50 per gallon to $3, I'm probably not going to cut back on my driving that much because like I need to drive places or specifically I'm not going to cut back on like the number of gallons of gas that I buy because I need to get somewhere. There's nothing else to use. So even if the price is high, I'm not going to like withhold my withhold the quantity or the number of gallons of gasoline that I buy. Okay, so that's determinant number 1. Determinant number 2 is whether the good is a necessity or a luxury. So necessities versus luxuries. Okay, what is a necessity? What is luxury? A necessity is something you need. A luxury is something you like, you don't need it. Okay, necessities are going to have inelastic demands. Luxuries are going to have elastic demands. Okay, think about why this is true. An example of a necessity right now is Wi-Fi. So like, you just need to have it in order to like live your life and operate. So what economics would tell us is that Wi-Fi is going to have a very inelastic demand. So even if they increase the price of Wi-Fi, you're probably not going to like cancel your subscription because like you need it. So the price can change a lot. So the denominator can be big, but you're going to get a very small or potentially no change in the quantity demanded. So the numerator of that ratio, the percent change in quantity demanded, is going to be tiny relative to the denominator. The whole ratio is going to be small, and you're going to have an inelastic demand. Okay, luxuries are things like yachts. So I don't need a yacht. So if the price of a yacht goes up by a lot, well, I just won't buy it. So in that case, my quantity demanded has changed. It's moved from something to 0. And so because the percent change in the quantity demanded is very responsive to the price change, luxuries such as yachts are going to have elastic demands. Okay, determinant number 3 is going to be the definition of the market. Okay, the rule here is that the more narrowly defined a market is, the more elastic its demand is going to be. Okay, so I'm going to write and then explain. So, narrowly defined markets have more elastic demands. Okay, what are we thinking about in terms of narrowness of a market? So, I'll give you an example so you can have something concrete to hold on to. So one market is a market for coffee. That's a pretty broad market, because within the market for coffee, you've got lattes, you've got cappuccinos, you've got just straight up brewed coffee, you've got all these variations of coffee. But there's also a particular market for like Keurig K-Cups. That's within the broader market of coffee, but it's a very narrowly defined market. Okay, what we are saying is true is that for markets that are more narrowly defined, those markets are going to have a more elastic demand. So think about this in terms of two markets: the markets for coffee, which is very broad, and the market for Keurig K-Cups, which is very narrow. The market for Keurig K-Cups is going to be elastic, because if the price of K-Cups like triples, then you're just going to stop buying K-Cups and you're going to switch to some other kind of, you might just get ground coffee and just make it old school. And so in that case, there's been a big change in the quantity demanded of K-Cups. So in that narrow market, price changes like really matter in terms of how people respond. But in broader markets, like the market for coffee, well, if coffee in general, if the price of that triples, well, you're probably not going to like just stop drinking coffee. You're probably going to drink less of it. But you're not going to just like totally forsake coffee consumption. So the broader a market is, the more inelastic the demand is. The narrower the market, the more elastic the demand is. Okay, the last determinant. I'll erase and put it up here. The last determinant is the time horizon that we're thinking about. So the way this works is that demand for a particular product is going to be more elastic over longer time horizons. Okay, so write first and then talk. So demand is more elastic for a particular good over longer time horizons. Okay, let me give you an example of this. Suppose I am a baker and I have like this recipe for biscuits and it has particular ingredients in it. So maybe one of the ingredients is buttermilk. So this is one of the ingredients for my biscuits. Okay, so I am a demander of buttermilk because I need it to make my biscuits. Okay, if I go to the grocery store and I see that the price of buttermilk has doubled, well, on that day, I know I need to make biscuits. I don't really, right now, have a good substitute for that because I haven't, like, rethought the recipe. So today, I'm just going to go ahead and suck it up, buy the buttermilk, even though it's expensive. So today, even though the price has increased some amount, I'm not really going to withhold my consumption by a lot because, like, haven't really, like, adjusted to the price change. So in the short term, my demand for buttermilk is kind of inelastic. But if the price never drops, if buttermilk like stays perpetually high priced, well then what do? I go back to the kitchen, I kind of retweak the recipe and like take out the buttermilk and put in something else. And so a month from now, when I go to the grocery store and I see that the buttermilk is really expensive, well then I just don't buy it. I use the new thing that I've used to replace the buttermilk with. So in the long horizon, I can kind of adjust to the price change and actually withhold my consumption. So demand is going to be more elastic, or I'm going to cut back my consumption of the good more when I'm thinking about time periods that are further away from today when the price change is happening. Okay, so those are determinants of price elasticity of demand. Now let's think about how you actually calculate it. So what I've told you so far is that elasticity of demand, I'm going to use epsilon to denote it, is equal in a general sense to the percent change in quantity demanded, or I'm going to put absolute values around this, over the absolute value of the percent change in the price. Okay, the way you calculate a percent change in something is you take the difference in an original level and a secondary level, and then you divide it by the original level. So what this is going to be is the numerator is going to be some quantity that you demanded. So, okay, let me start. Take a step back. Okay, if we're going to measure percent change in something, that means something has to change. So we have to have an initial quantity demanded, and then we have to have a secondary quantity demanded. So what I'm going to do is I'm going to put subscripts on the quantity and the price, and those are going to denote whether we're thinking about the original quantity or the second quantity. So the 2 means we're going to think about this quantity demanded number 2. Okay, so the percent change in the quantity demanded is going to be the second quantity demanded minus the first quantity demanded divided by the first quantity demanded. This will be the numerator. Put absolute values around this. And then the denominator is going to have a similar pattern. So the percent change in the price is going to be the second price you observe minus the first price divided by the first price. Okay, this is memory work. You definitely need to know this for exams and probably future economics classes. If you like patterns, then that's great because this is a very pattern-oriented equation. So a percent change in anything is just you take the second thing, subtract the first thing, and divide it by the first thing, and then that works for the quantity and for the price. Okay, so let me give you some examples here. So, let's see, I'll write over here. Okay, so this is going to be example A. Suppose you observe 2 points. Point number one is there's an initial quantity at 100, and at a quantity of 100, the price is 50. So Q1 equals 100, P1 equals 50. And then another coordinate is after this first thing, the second thing that happens is that the quantity changes to 70, and when the quantity is 70, then the price, the second price, is 100. Okay, what does that mean? That means we can calculate the elasticity of demand. So elasticity of demand is going to be Q2 minus Q1 divided by Q1, absolute values. So we'll take 70 minus 100 divided by 100, numerator. The denominator is P2 minus P1 divided by P1. So it's going to be 100 minus 50 divided by 50. Okay, this is going to give us, in the numerator, a negative 0.3. And in the denominator, it's going to give us a 1. Okay, so the whole elasticity of demand is going to be equal to, again, we're taking absolute values, so it's going to be equal to 0.3. Okay, first of all, the first thing we need to do is we need to compare the final number, its magnitude, to 1. Because 1, again, is the pivot point that tells us whether or not this demand is elastic or inelastic. So 0.3 is less than 1, so that means that this demand is inelastic. Okay, graphically, let's just kind of think about what that means. So we have 2 coordinates. We could plot those on a price quantity grid. So the first coordinate is at a quantity of 100. There is a price of 50. So that would correspond to this dot. The second dot is at a quantity of 70, there's a price of 100. Okay, so these are going to be 2 dots that are on the demand curve. Okay, just kind of think about now how this all lines up. So when we did the math, we said if you have these 2 coordinates where you move from this dot to this dot, then the elasticity of demand is going to be 0.3, which is inelastic. And inelastic demand tells us that people aren't super responsive to price changes. Okay, that lines up with the picture because in the picture we can see that the demand curve is pretty steep. So the price here, it's changing by quite a bit. The price change, again, is the denominator. But the quantity demanded, it doesn't change by too much. So the numerator is kind of small. So what that means for us is that the steep demand curve lines up with kind of a big denominator and a small ish numerator. Okay, again, just ingest this for a minute. So if you have a steep curve here, then that means you rise a lot more than you run. The rise is going to correspond to the change in the price. So if we're rising a lot, that means the price is changing a lot. That means the denominator is pretty big. The run is going to correspond to the quantity. If the run isn't super big, that means the quantity change isn't super big, so the numerator is going to be kind of small. So that's going to mean we have a big denominator, kind of a small numerator, just based on the steepness of this. And so overall, we're going to get an inelastic demand. Okay, let me give you one more example, and then I'll set you free to practice this on your own. So example number 2 is, let's suppose we have 2 new coordinates that exist along a new demand curve. Okay, so example number 2, or I'll put B, is let's suppose we have one point where the quantity, so Q1, equals 100, and then the corresponding price, P1, equals 80. And then we have another coordinate, the second one, where Q2 equals 200, and the corresponding price, P2, is going to equal 60. Okay, let's calculate the elasticity of demand. So the numerator is going to be the difference in the quantities divided by the original quantity. So it's going to be the absolute value of 200 minus 100 divided by 100. The denominator is going to be the difference in the two prices divided by the original price. So it's going to be the absolute value of 60 minus 80 divided by 80. Okay, when you do the math, the numerator ends up being 100, the absolute value around it, and the denominator ends up being negative 0.25. Again, we have the absolute value around it because we want to drop all the negatives. We don't care about the sign. We just care about the magnitude of the whole thing relative to 1. Okay, when you divide this, you get an elasticity that's equal to 4. Okay, 4 is bigger than 1. So that means that this good that we're looking at has an elastic demand. Okay, now let's bring this back to the graph and just verify that all the intuition holds. So we can plot these 2 points on a PQ space. So one dot has a quantity of 100 and a price of 80. Another dot, the second one, has a quantity of 200 and a price of 60. Okay, if these 2 dots reside along the demand curve, then when you connect the dots, you get a demand curve that's pretty flat. Okay, this should make sense, right? Because what we found is that the demand is inelastic. That means people are super, super responsive to price changes in terms of how many units they demand. So what we see here is that when you change the price by just a little bit, in other words, the denominator is small, you get these huge fluctuations in the quantity demanded, which means the numerator is big. So you've got a large numerator relative to the denominator, so the whole ratio is greater than 1, so again, it's an elastic demand. Okay, so for words, so a flat, I'll put quotes around this flat, a demand curve that's not super steep, a flat demand curve is in line with an elastic demand because the the price change, or the denominator, so I'll put the price change slash denominator, will be relatively small compared to the quantity change, Q delta slash the numerator. And so if you have a big numerator and a tiny denominator, then again the whole ratio is going to be large, it's going to be bigger than 1, and we're going to have an elastic demand. So visually in your mind you should see a demand curve that's not steep at all. Okay, so during the next 10 minutes, make sure you look over this equation, practice a little bit, and then after 10 minutes, and all your questions, if you have any questions, I'll give you some examples to practice on. Okay, for the exercise, you're just going to practice the math that I showed you during the lecture. So there's going to be 2 questions, and each question has a part A and a part B to it. So question number 1, suppose there exists, the backwards E means there exists. Suppose there exists 2 points on a demand curve. Point number 1 is the quantity is 80, the price is 2, and the second point is the quantity is 60 and the price is 4. Okay, part A. What is the elasticity of demand? So you need to take the formula you have and calculate a number for the elasticity of demand. Part B is based on the number you get, is the demand elastic or inelastic? As a hint, all you need to do is take your answer to 1, or take your answer to 1A and compare that number to the unit 1. So is the number you get larger than 1 or smaller than 1? Number 2, exact same thing, just different numbers. So suppose there exists 2 points on a demand curve. Now the first point has a quantity of 4 and a price of 100, and the second point has a quantity of 12 and a price of 60. Same question. So part A, what is the elasticity of demand? Part B, is the demand elastic or inelastic? So just two problems. You're doing the exact same steps, just with different numbers for practice. Once you have a total of 4 responses entered in Blackboard, you're good. Make sure this is clear, and we're going to build on it for next class. So I will see you then.